Hello, sixth graders. Welcome to our next math lesson. Today we're going to talk about lesson 109. It is dealing with corresponding parts as well as similar figures. And today we're going to start, our lesson begins on page 566. Now we're going to talk about congruent figures again today, but we're also going to talk about similar figures. What's the difference between congruent and similar? Okay, we're going to talk about that today. So we start off by saying the two triangles that are shown below here, they are congruent. And again, as a review, the word congruent means they're the exact same shape and they are the exact same size. Now, each one of these triangles here has three angles. So angle 1, 2, 3, and we got 1, 2, 3. So they all have three angles. They all have three sides. One side, here's 1, 2, 3, 1, 2, 3. Okay. The angles and the sides of triangles A, B, and C, they would correspond to the angles and the sides of triangle X, Y, Z. And the word correspond means they are going to be the same. So if we take a look at our next page here, we're going to see that if I were to take this figure here and I were to do some transformations, which was part of our last lesson, which means I'm going to rotate this, and then I slid it over, and then I reflected it. I would see by rotating this, translating it, and then flipping it, you should see that letter A would go on the top and would slide over. That means letter A corresponds to letter X. Now that's important for us to know, because what that means is anything that letter A is, letter X is going to be the exact same value. So for example, if I said that this angle right here was 30 degrees, I'm just putting a number here. If this angle right here would be 30 degrees, so let's say A is 30 degrees. Let's put a 30 in there. Let's say A is 30 degrees. If this angle right here is 30 degrees, you should be able to tell me then that, well, since A corresponds with X, and this figure is the exact same size as this figure, that means letter X should also be 30 degrees. Okay, so A would correspond with X. If I were to rotate this, translate it, and reflect it, you should see that letter B would actually match up with letter Y. So B is going to correspond with letter Y. And again, if I said that this number here was like 50 degrees, it's not obviously, but if I said that this is 50 degrees, that means you should know already that angle Y would be 50 degrees as well, because they correspond with each other. Just like letter C, this angle right here, which happens to be a 90-degree angle. If this is a 90-degree angle, that means letter C corresponds with letter Z. So if I knew that this is a 90-degree angle, that should automatically tell me that letter Z is also a 90-degree angle as well. So the angle measurements, A would be equal to X, B would be equal to Y, and C would be equal to Z. So the angles would be the exact same measurements. But not only would the angles be the exact same measurement, but also the side lengths would also be equal as well. That means then if I had side AB, this line right here, this AB, okay, connecting from A to B, that would be the exact same as XY right here. Because again, if I were to rotate it and I translated it and then I reflected it, this line right here, AB, would lay right on top of line XY. And that's important because if I said that this was 7 inches, if AB is 7 inches, then already we know what the length of XY is going to be. If they correspond with each other, if AB is 7 inches, that means XY would also be 7 inches. This one would be 7 inches. Should notice that side BC right here, side BC, if I were to rotate it, translate it, and reflect it, BC would line straight up with YZ. Okay, so if I knew that this one was, let's say this is 2 inches, automatically I know that this would also be 2 inches because they correspond with each other. And now I'm left with AC, this line here, AC. Again, if I rotate it, translate it, these two line on top of each other. So AC is going to correspond with side XZ, okay? So having two figures that are congruent to each other, they're nice because that means the angle measurements are going to be the exact same. It also means that the side lengths are going to be the exact same. So we can use that information to help us solve this problem here. It said these two triangles are congruent. They are congruent, which means they're the same size and they're the same shape. So what they're saying is, what would be the perimeter of each one of the figures? Well, here's the good news. If we can find the perimeter of one of them, the other one is the exact same number, because congruent means they're the same size and they're the same shape. So now what we have to do is figure out the missing numbers, because on this side over here, this side right here doesn't have a number, so I'm trying to figure out this one. And over here, this one doesn't have a number to it. But we can use these two triangles to help us figure out the missing numbers. Now you should notice that this line here is 4 inches. This line right here is 4 inches. That means that this side here corresponds with this side right here. So if this is 4 inches, this will be 4 inches. Now let's take a look over here. This one's 3 inches. Hopefully by now you've started to realize that, well, this side right here, if I were to rotate it and slide it over and then flip it over, it would correspond with this side right here. And since they are congruent, which means they're the same size and they're the same shape, if this is 3 inches, that means this one right here should also be 3 inches. Okay. And just like this long side right here is 5 inches. This right here should correspond with this side right here. So if this is 5 inches, that means this one's going to be 5 inches as well. Okay. And now all I have to do is really just add one of them together. Because if I add one of them together, the other one should be the exact same size. So if I take 3 plus 4, 3 plus 4 gives me 7, and then I would want to add 5 more, 7 plus 5. That means this perimeter here is going to be 12 inches. And since this one's 12 inches, we know this one would also be 12 inches because it's the exact same numbers. So when they're congruent, that's nice. That means the corresponding sides would have the exact same measurements to them. The corresponding angles would have the exact same measurements to them. That's pretty nice. But today we're also going to talk about similar objects. Now, there is a slight difference between similar and congruent. Figures may have the same exact shape, but they're not necessarily going to be the same size. So we would call those similar figures. Again, let me repeat that. They have the exact same shape, so they have the exact same layout, but they don't have to be the same size. Okay, so right below here, 3 of these figures, 3 of these triangles are similar to each other. I got triangle 1, triangle 2, triangle 3, and triangle 4. 3 of these triangles are actually similar. All right, so let's take a look at our explanation here. Triangle number 1 and triangle number 2, these two are actually going to be similar to each other. As a matter of fact, these two are actually congruent. That's what it says. They're also congruent because you have that is the exact same shape and they're both the exact same size. So that means that this side here would be the same measurement as this side. This slanted side would be the same measure as that slanted side, and this side here would be the same side as this one. Not only that, but the angles would be the same. So this angle would be the same measurement as this angle. This angle would be the same measurement as this angle, and this angle right here would be the same measurement as this angle right here. So angles 1 and 2 are similar, and they are also congruent. But now let's take a look at triangle number 3, because triangle number 3, this is definitely not the same size. This one's a lot taller, but you should notice that it is the exact same shape, same type of triangle, just different size. Now that's important because if 2 things are similar, that means the side lengths are not going to be the same number. So if this was 3 inches, this would definitely not be 3 inches. So the side lengths are not going to be the same. But in similar figures, the angles will be. So what I mean by that is if this angle right here, let's say this one is 30 degrees, we already know that this one will be 30 degrees. Since this shape over here is similar, that means that this angle is also 30 degrees. These two would be the same. The angle measurements are going to be the same, but the side lengths are not. And obviously, this side length is going to be longer than this side length. Okay, so triangle 3 is actually similar to triangles 1 and 2. It has the same shape, but it does not have the same size. Notice that the corresponding angles of similar figures have the same measurement. Just mentioned that this is the same as this. That means this angle right here would be the same measurement as this angle right here. And this angle right here would be the same measurement as this angle right here. But you should notice that triangle number 4, even though it is a triangle, it's not the same type of triangle that 1, 2, and 3 are. So we would say that triangle number 4 is not similar. Okay, so I want to review that. Congruent means same size, same shape. 1 and 2 are congruent. Similar means they're the same shape, but they are not necessarily the same size. So 2 and 3 are similar to each other. You could also say that 1 and 3 are similar to each other. If they're not, like number 4, we would say that they are neither congruent nor similar. Okay. All right, so let's look at our example here. It says the 2 triangles that are listed here, they are both similar to each other. Now it's important because similar means same shape, okay, but they're not exactly the same size. And you should notice that this triangle does not go nearly as high up as this triangle does. But they're asking a question. What would be the measurement of angle A? Okay, now we don't know the side lengths, but that's okay. With similar figures, the angle measurements would be the same. And I hope you realize by now that this letter A would correspond to this angle up here, which is 30 degrees. So if this is 30 degrees, that means that letter A is also going to be 30 degrees. Okay. If I were to ask you, students, what would be letter B? What would be the angle? What would be the measurements of angle B? I'm going to write A here on this one. If I said, what's going to be angle B? Well, if this one's 60 degrees and this one corresponds with that, then letter B would also be 60 degrees. And you can use that same logic, boys and girls, to figure out what would be the measurements of angle C. Angle C, well, angle C corresponds with this angle right here. And if this is 90 degrees, that means letter C would also be 90 degrees. Okay, so with similar figures, the angle measurements are going to be the same measurement. That does not change. What will change, though, is the side lengths. So here are 2 important facts for you to remember about polygons that are similar to each other. Okay, number 1, the corresponding angles. This is important. The angles are going to be congruent, which means they are going to be the exact same measurement. We just did that with our previous problem. A is congruent to this one, so A is 30, this one's 30. B is congruent to this one, so B is 60, this one's 60. C is congruent to this angle, so C is 90 degrees, this one's 90 degrees, okay? So if you have corresponding angles, they're going to be congruent to each other. Number 2, the corresponding sides are going to be proportional to each other. Okay, so the first fact means that even though the sides of similar polygons might not have matching lengths, the corresponding angles, they do match. We've talked about that already. The second fact means that similar figures are related by something called a scale factor. All right, a scale factor is a number. Just a number, like the number 5 or 7 or 3 or 2. Multiplying the side length of a polygon by the scale factor gives you the side length of the corresponding side of the similar figure. So this is a fancy way of writing, look, if you're going to multiply one of the sides by 3, you need to multiply all of the sides by 3, which means the scale factor is going to be 3. That's just, whatever you multiply each side by, that's the scale factor. Okay, whatever you multiply each side by, that's the scale factor. And you have to multiply all the sides by the exact same number. You can't multiply like one of them times 3 and the other 2 by 4. Then they wouldn't be similar to each other. They just wouldn't be. Okay. All right, so let's take a look at this. Here's an example of what we're talking about. The 2 rectangles that are listed here, they are similar. You can tell they are both the same shape. They're both rectangles, but they're not the same size. This one is obviously bigger than this one is, okay? What it's asking for is, what is the ratio of the corresponding sides? If you can figure out the ratio, scale factor is the exact same number. So what's the ratio? Ratio means we got to have one number over another. So let's take a look here. Let's say BC. We know that BC is 4 centimeters. So I'm going to write 4 on top. That's 4 centimeters. Now, what side over here is going to correspond with BC? Hopefully you realize that FG is the corresponding side. So if BC is 4, that means FG, which is the corresponding side, which is 2, and that'll go right there. And so the ratio would be 4 to 2. And we can reduce that. And so the ratio in lowest terms would be 2 to 1. That's that ratio right there. Mr. Johnson, could you do that with the other sides that are listed there? Of course you can. Let's take a look at this one. Letter BA. Side BA is 2 centimeters. So I'm going to write 2 centimeters, 2. Okay. And you notice I'm always putting the bigger number on top. I like putting the bigger number on top. Now, if we look at BA, what side corresponds with BA on the smaller rectangle? EF would. So this side corresponds with this side right here. And since this is BA is 2, that means FE is going to be 1. And if we put that in lowest terms, which it already is, notice it's the exact same number. So when it says, what is the ratio of the corresponding sides? The ratio would be, I guess, for a fancy way to write it would be, for every 2 centimeters on the big rectangle, it's going to represent 1 centimeter on the smaller one. So the ratio would be 2 to 1. That's the ratio. When it says, what's the scale factor? Well, what did I multiply 2 by to get 4? What did I multiply 1 by to get 2? The scale factor is going to be 2, because I multiplied both of these numbers by 2 to get to bigger sides here. Now the good news is that this is a 90-degree angle, this is a 90-degree angle. So again, the angles are the same number. It's just trying to figure out the side lengths. And when you go to write the ratios, remember what I said, put the bigger size number on top. Put the smaller sided on the bottom. You may have to put in lowest terms, but when you do that, you should notice that they all give you the same ratio, 2 to 1. And the scale factor would be, well, 2 to 1. Scale factor is basically this ratio written as a whole number, which is 2. So the scale factor is going to be 2. All right. I hope that wasn't too confusing for you, 6th graders. If you take a look at your assignment for today, you're going to do pages 569 through 571. You're going to be doing letters A through 24. Don't hesitate to go back and look at the video again, especially that part about the scale factor that could be a little bit challenging. Hopefully you understand how to write those as corresponding parts. If you have questions, especially on this lesson, boys and girls, do not be afraid to reach out to me. I'm here to help you the best that I can. So I wish you good luck on this lesson. I hope I didn't confuse you too much with it. Don't be afraid to reach out. Watch the video again if you need to. So good luck with it, and we will see you with the next video.